And welcome to this video where we'll cover Onshape surfacing and equation-driven sketches. Some of the benefits of this is I've got here a surfaced converter shell. It's a clamshell design, and when I want to change something, there are so many sketches to change when you surface that it can be very painful to make changes. However, using equations, I can just change, say, my overall length from 8 to 10 inches. And as Onshape rebuilds this, I get a longer subsequent length. This really simplifies things and makes it easy to generate a family of parts very quickly. Likewise, I can make my inner radius from 1.75 to say 2.25 inches. And again, we are instantly regenerated. And then I can make my outlet radius something like 1.125. And I can build a whole new converter shell basically instantly right on the cloud with the help of OnSketch. So let's go into the principles of both equation-driven curves and sketches, as well as how to surface in Onshape as well. I'll create a new document, and we'll call this Surfacing Tutorial. And from here, I will start by sketching on my front plane. And there's a few, perhaps I'll even, before the sketch, start by making a few variables. I know that I want to have my overall length, and I'll want that to be, say, 8 inches long. And then I'll make another for my inlet radius, the radius of my shell, and that would be, say, something like 1.75 inches long. And then I'll make another one for my inner length, or what length of maximum size substrate I can fit into this. I'll make that something like 4 inches. Then I'll do my neck length, or what length of neck that I want to have on my inlet and outlet. I'll make that, say, 1 inch. And then I know I want to have a lateral radius, and I'll make that something like, oh, ½ inch, maybe 1/8 inch. And then I know eventually, not in this sketch, but eventually I'll use an axial radius. Eighth inch is a good value for that as well. I know I want to have a lip width eventually. And I'll make my lip width something like 0.375 would be great. Okay, so I'll start sketching on my front plane with my newly created variables. And I'll make my view normal. I'll create a general outline of what half of my converter shell will look like by its profile, and this would be a guide path. I'll choose these points and make fillets. Okay, now that I'm done with my sketch fillet, oops, and I've exited my sketch, I will delete this dimension. Now I'll use the D key to make a dimension, and I'll take my overall length, and of course I use a pound or a number sign, some people call it a hashtag, and add in overall, length. And then I'll divide that by 2 because I'm dealing with only half the sketch. From here, I know that this will be the inner surface, and so I'll take my dimension and make it my inlet radius, which, because these shells are symmetrical, I can know that my inlet radius and my outlet radius will be the same, so mirroring it will not be an issue. Take this and make it my, oh, I seem to be missing a variable for this, so I will close out and add in another variable, inner radius, and I'll make this something like 1.75 inches. Actually, maybe something more like 2 inches. Yeah, 2.75. Now, because my sketch is here and my inner radius is below that on the history tree, I will not have that dimension recognized in my sketch. So I'll drag it up. Again, drag it up. Okay, I'll drag my sketch down, and now it will be recognized. We'll do a pound inner radius. Bear in mind, these are case sensitive variables. Hashtag oh, and sure enough, inlet radius. There we go. You know, I may want to reduce these variable values. Inlet radius I'll reduce down to 0.75. And my inner radius I'll reduce to 1.75. Be a little bit more proportional. Now my neck length and my inner length. Yep. That's a little SolidWorks habit happening. My inner length divided by 2 because I'm using half. And my neck length. Now I can dimension my overall length. And we are finally done. I just need to make a construction line. And I'll mirror. And that's our first profile. I want to create another plane because this is simply a guide path. So for our surfacing, I'll select a plane, click on the plane button, and choose offset plane point to here. Now that I've just generated plane 1, I will select sketch and create our first lofting profile, as this will be a lofted surface. With this plane, I will normal the sketch plane and make a arc. Choose the end of my other sketch. If you can see the end of the sketch that I'm choosing, I guess here and here to make coincident. Go back to normal. And I'll choose a dimension to make inlet radius. From here, it's probably easiest to make another construction line and make this tangent to horizontal. Now I need another, I'll do a tangent arc and make it horizontal to the origin. We'll give this the dimension of axial radius. Since that doesn't seem to want to cooperate, actually I don't even need to do construction, I'll simply do a line. And I'll make this tangent. And now my line can be given a dimension of my lip width. And because I've got an arbitrary line here, I'll just make those equal. Now I can choose a mirror function. I'll mirror across this line and these parts of the sketch. And we've created our first sweep, or our first lofting rather, profile. So the big lesson here is when we loft, we have 1, 2, 3, 4, 5, 6. So we want to have 6 elements in every subsequent profile, or we will not loft very smoothly at all. So I want to make another profile now, and it will be of this laying down. You can see that we may not have the exact same angles as this, because this is all part of our regular radiuses, but on our next profile, which we start here, we have to account for this extra radius length. So I'm going to hide my first plane. In fact, I'll just sketch on my top plane. And I'll view from the top. And I'll start off by making a line. And of course we want to start here, so I'll make it coincident. And I want to maintain the integrity of my neck length, so I'll make these equal. I'm going to start making a point that is vertical with my origin, and I'll run an intermediate point in between. Now from here we'll make these vertical, and that will ensure that we have a consistent inner length. Actually, I'll get rid of this line because I want to add 3-point arcs, and a sketch fillet won't suffice here. So I'll do my tangent arc on either end with the line running in between them. Now I'll add in a dimension and make sure that I've got my lateral. I should pound lateral radius. And I can make these equal. Likewise, tangent. Finally, we'll make this, I have to make this equal to inner radius plus, and then I have to choose my axial radius as well. And we're fully constrained. Finally, I'll mirror. Create my mirror line. Mirror across this line, these features. I will regenerate the same sketch over here. By sketching on my top plane. Okay, with this same sketch, I can now mirror. Now going back to our isometric view. I want to make another outer profile, and so I'll begin sketching on my top plane again. Old SolidWorks habit there of double clicking to end the line. And since we're vertical, I'll create a dimension, and this will be my outer lip width. Another SolidWorks habit. There's our lip width. I'll do the same by making these coincident. Make this vertical. Finally, I use a center point arc, and that way I can make sure that I am concentric with this arc. Of course, I don't think I can snap to geometry until after it's been sketched. Coincident. Tangent. For simplicity's sake, I'm not going to put a radius here. Perhaps I can put a fillet or something like that after I've generated my surface. But if I put a 3-point arc here, as the equations begin to change, I see this as being a real point of conflict and limiting the amount of dimensions I can put on. So for simplicity's sake, I will simply make this tangent. And it looks like I don't actually want to be vertical here. So we'll go parallel. It is a high priority to maintain this lip width, so I have the same width here, here, and here. If I do not, it may be difficult to weld the clamshell from a design perspective. Now, I'll make a mirror, choose this line, here, 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 here. And we're done with that sketch. I'll simply make a mirror image of that sketch. Tangent equal and concentric. Tangent. Now we can mirror. And we're done. We are almost done with all the profiles that we would need to sketch out. So we've got our inner and outer profiles. I think yeah, that's looking good. I will now sketch on the right plane my inner profile, and that will be one of the last profiles I need to sketch. Now that we're sketching on the right plane, I'll get normal. And I'll start with a 3-point arc. And it may be easier to look at this at an angle. I'll add in my inner radius dimension. And add in a tangent arc. We'll make this coincident. And tangent. Finally, we'll make this have an axial radius. I have to use my pound sign. And we'll make these coincident. There we go. So I can mirror. Excellent. And we're starting to have what looks like a converter. I don't know if these planes will be all that useful anymore, so I'm going to hide them so we can have a better look at our sketches. Now I need to copy or replicate a few sketches. I'm going to start by creating a plane. And selecting these 3 points. And instead of offset, I'm going to make a 3-point plane. Well, clearly that's a little bit angular. So instead of a 3-point plane, I would like to use these points due to that's where I want my neck to be. And it would be easiest to run my profile that way. So to accomplish that, I'll choose plane, and I'll choose my right plane, and perhaps I'll choose this as a point. This is my plane point. There we go. And I have plane 2. That looks much better. I will sketch on this plane. And I can use my use function found here. And I no longer need to see this plane. I'll create another plane. I think it would be most useful to add one here. And make this 3-point. Now I'll sketch on my plane and use the use function as well. We're done. I can hide this plane now. I'll create another plane. on this side. Adding these extra planes for these extra profiles when we loft will help us to have a far smoother and more reliable loft. 3-point, and use when we sketch on it again. Of course, Onshape simply creates these sketch entities with relations to the other sketches that I'm copying from. So all of these sketches update simultaneously together. From here, I will hide this plane. Now I'll make another plane. And we will choose 3-point. Oh, made the same mistake as last time. In which case I'll choose this point, choose a plane, and then select my right plane again. And I'll choose plane point, and now I've generated a vertical plane. Back to my trimetric view. I'll sketch on this plane, and again choose use. Now I will hide my plane. Finally, I can choose my last 3 points to generate my last plane. Sketching on this plane again. Use. And those are our sketches that we need to have. I'll hide this plane. Now we're ready to begin surfacing. I'll choose my loft and choose surface. Now with my new surface, I can choose my profiles. My first profile will be closest to us, sketch 2. Now I can choose the next one down my history tree, sketch 8, 9, 7, 10, 11, and 12. I can go to my top view. I can choose guides and continuity, or rather, perhaps path. I can begin by going from one side to the other. Notice I'm having a little bit of a difficulty here, and I think that I need a radius here because Onshape doesn't know how to interpret a sharp edge. So if I exit out and go ahead and edit this sketch, this will be a good exercise for troubleshooting and seeing how these sketches can update. I'm going to simply add a sketch fillet over here. I'm going to, whoops, I got out of the sketch. And likewise, I'll add in a sketch fillet right here. But I'll remove the dimensioning. Make these equal. and then add a dimension of my lateral radius. Now I've got a few inconsistencies. If I open up this sketch, I've got some problems here because some of the references that I've made are now replaced by a sketch fillet. I'll delete this line. Notice I've correctly gone back to my vertical relation. And so I'll choose a 3-point arc, or I should say a tangent arc. They're very handy. And made it equal. Line. Again, we should be tangent. And we should be tangent. And now we're fully constrained. Coming back here. Tangent, tangent, and we're fully constrained. Now we have a few plane, oh no, it looks like our sketch planes. There we go, our sketch plane is struggling here. This is plane 5. So I'll go back to my isometric view. And I'm going to edit the definitions of this plane. I'm on a plane point, so I'm going to get rid of this vertex and select a correct vertex. And now our sketch is snapped back into the right spot. Everything else appears to be correct. So let's begin again, and I believe that we will have a successful loft. Lofting, new, we'll go with surface, and I'll begin to choose my profiles from my history tree. Of course, I just choose them sequentially, every sketch that's moving further away from us. Now viewing from the top, we have the same thing. We have the varying thickness on the lip, and it's doing its best with what it has been given, so let's help out Onshape a little bit more by giving some guides. I'll just choose the guides from one side to another. 5, 3, 1, 4, and 6. And we have used every sketch that we have made. Our preview is looking very good. Now that I have this surface, it is very easy to thicken the surface. And I can do that by choosing Thicken. And I can choose all the faces that I wish to thicken. This, of course, is quite thick, and these shells will be thin gauge metal. I'll make this an arbitrary 30 thou. And there we have our shell. If I wish to test this, I can choose overall length, perhaps 10. And we're longer without error. My inlet radius, 1 1/8. And again, larger without error. Inner length, I can go with 5. Perfect. Inner radius, I'll go with 2.25. Brilliant. Lip width, Maybe I'll go with 0.75 and give it huge lips just to test out. And it works. And so we have a converter that we should be pretty happy with. Again, this covers the principles of surfacing and equation-driven sketches so that when we go to edit these things or create families of parts, it is very easy to edit. I hope this video was helpful, and please subscribe as that's the best way to help me back. I'll catch you in the next video.